welcome them.
Thank you, folks.
Thank you so much.
Good.
So actually, the idea behind this talk sort of actually came to happen at a KubeCon.
Yeah.
We were in KubeCon Japan. Mauricio and I were discussing OpenTelemetry, Dapr. There must be some interesting stuff we can do there. And you were working on asynchronous workflows. And yeah, why not try to do that?
Yeah, definitely. And I think that this presentation is the result of an ongoing collaboration that we are doing, and we want to expand this work across other projects in CNCF as well. So if you are a project maintainer, or if you want to contribute to a CNCF project, this might be kind of like one of the.
Exactly. But first, maybe a small introduction to who we are. As Ricardo also mentioned, my name is Kasper. I work as a principal developer advocate at Zero. Did the KubeCon thing. I'm also a CNCF ambassador and been doing a lot of things surrounding community in the Nordics. Also took all the certifications in the CNCF, so I'm also a Golden Kubestronaut. But yeah.
Good stuff. Yeah, so Mauricio, Salatino. I work for a company that's called Diagrid, and we are the main kind of contributors behind the Dapr project that we are presenting about today. I wrote the book about platform engineering a long time ago, like 2023 or something, and I need to update it with all the AI stuff that Engin has been talking about. Yeah.
Yes. So if you walk away from the session with something, maybe hopefully it's going to be this. So if your applications and infrastructure grows in complexity, you must have the right tools to understand what is going on at all times. That's really sort of the key thing in this talk. So let's see if we can sort of flip up to that.
Yes.
So why asynchronous communication is powerful? Well, we all probably know this journey, right? That we started like 10, 15 years ago, 10, 12 years ago with microservices. We were all doing monolith at that time. Then microservices came around with the smart endpoint, dumb endpoints and smart pipes. No, it's the other way around. Yeah, I can't remember. It's a long time ago. But now every day, like everybody's doing like event-driven microservices or some kind of asynchronous communication going on in their architectures. And you all know that just to make sure that we sort of align what we're talking about, synchronous communication, we all know that it's like a client sending a request to a server and the server responds. This, of course, has some limitations and some issues that if you have too many requests, the latency will increase, there's some tight coupling in time, and if the server is not available, you will have downtime. Of course, Cloud Native can do a lot of things in this space to help this out. But it comes with these limitations. Then the asynchronous part is, there's of course all kinds of different ways you could do this, but the whole idea is that we're introducing like a message broker or some kind of queue where we can push things to, and then at some point a consumer will come around and do some things, or do some work. That's the whole idea. And I know synchronous communication for many, at least, is most likely like a familiar space, whereas we know that asynchronous communication is really powerful, and in reality, you probably need some asynchronous workloads and some asynchronous workloads.
Yeah. And it's kind of common, like if you want to start building resiliency on top of your applications that you already have, like adding some asynchronous mechanisms like message brokers will kind of like help you in that regard. So we will need to explore that in a bit, right?
Exactly. But yeah, let's start with a small demo, because Mauricio built this cool pizza app. So
So I said, let's build a simple application that do a couple of things. Imagine how that went. It went pretty complex, pretty fast. And this is just a very simple, pizza application store where you can place different orders, add more pizzas, you can add some drinks, and then the idea is that you place this order to the store, right? And the store is composed by different services. So what you will see down in the bottom is like different services processing the order, right? So the store receives the order and said, hey, I got the order. And then depending on how many pizzas did you order, it will start sending this, let's cook this in the kitchen, right? So we have another service that is actually cooking the pizzas. And what you see here, like on the events column, is basically the services reporting back state. Like if they are making progress, right? Like the pizza has been cooked, now the order is ready to be delivered, so we call the different service that it's going to be in charge of doing the delivery of that pizza order, right? And at the end, of course, like whenever the pizza arrives to the person that orders it, the order is completed. This is kind of interesting because we have a lot of things going on, even if it's a very small application. So let's take a quick look at the architecture from a very high-level point of view, right? So as I mentioned before, we have a front end that it's like something that is being sent to the mobile app or like the front end, like the web application as well. We have a backend service for that front end, and then like we do REST communications between the kitchen and delivery services to process the order. But all the reporting back state and progress, we do it via Kafka, sending messages back to the UI, and the UI then will use WebSockets to report back to the user about what's going on with that specific order. Right? So in order to implement this application, we started thinking, okay, which patterns of asynchronous and synchronous communications are we using? And for that reason, we started looking into projects like Dapr that will simplify how developers build these applications that basically uses different behaviors, different patterns that are well understood already. And that's why I wanted to talk a little bit about what Dapr is and how it works on top of your Kubernetes clusters, because Dapr is a graduated CNCF project. But in my opinion, because this goes a little bit closer to the developer side of things, is less known in the infrastructure side of things. And I think that it's good to understand how this can help not only developers, but also like the infrastructure team that it's provisioning infrastructure for these developers to access. And when I'm talking about the infrastructure, I wanted to specifically mention in this case like all the message broker side of things that we have been mentioning, like Kafka in this case. So Dapr, like from a very high level, is just a set of APIs to help developers to implement all these distributed system patterns by providing APIs that they can use from inside their applications. There are like different APIs, like PubSub API for doing these asynchronous communications with the message broker in the back. But recently, we have been doing a lot of workflows and async interactions and orchestrations. And there are like conversation APIs, like APIs to access configs and secrets and all that stuff. And behind all these APIs, we implement like cross-cutting concerns like security, resiliency, and observability. Being observability the thing that we wanted to cover with Kasper in this presentation. So how does it work? Pretty quickly. You have a Kubernetes cluster. As I mentioned before, we have a service that is called the pizza store. And this pizza store needs to be sending or consuming messages from a message broker like Kafka, right? You install Kafka into the cluster, and then you need to actually connect your application to this Kafka cluster. Usually, you will do it by adding a dependency into your application, like the developer will need to add this dependency that needs to match with the version of the message broker that you're using, right? So now you have an application that is very dependent on the message broker that you're using. So if you want to move this to a cloud provider, for example, to use Google PubSub or Amazon SQS, you will need to change and recreate your pizza store container, for example. So how does Dapr helps in that scenario? You install Dapr, like a Helm chart in your cluster. And then what Dapr will do is basically it will allow you to decorate your applications and say, hey, I want to use one of these Dapr APIs that you are providing, like the PubSub API. Whenever it detects that, it will automatically inject a sidecar into the application, exposing these APIs and basically providing these like clients to connect to infrastructure, right? So in this case, the Dapr sidecar will connect to the message broker, delegating all the responsibility for that connection, the connection pools, and the connection configuration to this sidecar in this case. The application no longer needs to know about how to do that. And then the application can start basically publishing and consuming messages from this broker or any other broker that Dapr supports, so you can swap the implementation behind the covers. In the same way that you do PubSub in this case, we have also like service-to-service invocation to do like REST requests across different services with service discovery, but also implementing filters, MTLS, retries, and circuit breakers, removing again the need for developers to implement these with different libraries inside their applications and across different languages, right? Like you want to make sure that all these behaviors are kind of like consistent across different programming language stacks, which is very hard to do if you do it by adding dependencies to your applications. But with that, we only are solving kind of like the access to infrastructure and communication between services. What we want to talk about this is about like resiliency and asynchronous communications, and that's kind of like the workflow part of things that was created to improve resiliency on top of your applications with durable executions. So what's the idea here? What happens when something goes wrong, like a service goes down, or Kafka is down, or even the entire thing goes down? We want to make sure that if we receive and acknowledge an order for a pizza, we will deliver that order in the end, right? And that's pretty much what Dapr Workflows was created to do, just to provide resilient orchestrations that are durable and can support a lot of different kind of failures on the infrastructure and on the application side. Basically, you can codify, like you write like a sequence of things that needs to happen, and Dapr Workflows will keep trying to execute these things until they are completely done. How does it work? we have a workflow runtime inside the sidecar that was injected very close to your application that can execute these workflow definitions that you can create by coding them, right? So the workflow definition looks like that. In this case, very high level, processing an order, cooking pizzas, and then delivering pizzas. So if we receive an order and we create a new workflow instance, the workflow instance will make sure that if something went wrong, like on the infrastructure side, when we were cooking the pizzas, whenever things go back, we will just keep moving this order forward until it gets delivered. But things get complicated, right? Like now we have an orchestrator that is basically calling REST services, sending messages back, and it's kind of hard to understand what's going on there, right? Yeah, because it looks like that.
Yeah.
But with a lot of other things. Like that, right? Now we have, workflows calling services, things calling each other, sending messages. And if you want to see what goes wrong when something goes wrong in this picture, it is kind of like that.
It's not easy, no.
Yeah, because it's like shared across application logic, infrastructure, and Kubernetes itself.
Exactly. And that's why we need some observability, right? We need OpenTelemetry in this mix. So just a brief introduction to what OpenTelemetry is. It's an incubation project at the CNCF right now, trying to apply for graduation. Hopefully that will happen soon. But the main goal is really to basically standardize how we are collecting our telemetry. It has these main goals of like providing unified telemetry, it's being vendor neutral, and being cross-platform, meaning that you can use all the different languages that you are probably familiar with out there, and it should hopefully support that out of the box. It's actually it's the second largest project within the CNCF in terms of contributor count. This is from the last year, so look very much forward to see the velocity report for this year. But as you can see up there, it's very close to Kubernetes in sort of commits and PRs plus issues. So it's a really adopted project. I think there's around 90 projects within the OpenTelemetry repository, or GitHub repository today, or organization today. So there's a lot of stuff going on in this space. It includes the OpenTelemetry collector, which is sort of the way you are collecting telemetry when you're running inside of a cluster. You have some instrumentation, you have APIs and SDKs in the different languages that you're using. You can use auto instrumentation, which we will show you in a minute. You can also use OpenTelemetry collector to collect information from your Kafka cluster, from your Kubernetes infrastructure, from basically everything that you might have running. And then you basically process you can do some processing, you can do redaction of social security numbers or whatever you sort of want to remove. You can do all kinds of interesting things there, and then you can export it to some kind of backend, whether that is dedicated backend for the different dedicated signals or it's a unified solution. So what it basically does is handle this area where we are collecting all the telemetry that is basically being produced within inside of the cluster, and then we are pushing sort of the vendors downstream in this sense, that now vendors don't have like specific agents that you need to rely on and like you're being locked in. They are fighting in a different space further downstream, and you can basically just send the data to wherever you want. I think that's one of the key things about OpenTelemetry. It also comes with this operator that makes it easy for you to do a lot of things, but I want to talk about the instrumentation part in this talk, because it's basically has this CRD called an instrumentation that allows you to automatically inject instrumentation into different languages. So in this case, we will be using Java.
Yep.
So it can basically inject the Java agent from the OpenTelemetry project into your pods, and then you get like a good baseline of telemetry out of the box. So that was a lot of complexity. There are a lot of things, moving parts.
So now we have like a complex project. Now we have a setup for the observability side of things. We need to get all together, right?
And we have different roles, right? So I'm coming from a platform engineering side. Mauricio is more from sort of the development side. So we have different goals. We have the same goal, but we come from different perspectives, right? And we need to figure out how to sort of divide responsibility between the platform and between what the developers should do. Hopefully it is in a way where we as a platform, or me representing the platform side of things, can really help you as a developer. You don't hopefully have to do much, and you'll get a good baseline. And that's really what we usually tracing is kind of a hard thing to sort of like position because it's very application specific, right?
I think so, yeah. But also, like as a developer, I don't really need tracing until something goes wrong, and then I really want to understand what happened, so I can just go and fix my application. So it's one of those things that the less that I can do, the better. But at the same time, I just need to have some.
Exactly, but you also want to understand like the full picture of where your services are in this very distributed system, right?
Exactly,
So. And luckily, this is where we as platform engineers comes in and could use something like Dapr to provide these abstractions to what Mauricio was talking about, adding these service invocations, asynchronous communication and stuff like that. But also from the observability side, this is the OTel operator, the OpenTelemetry operator, injecting the Java agent into the pizza store service in this case that are like developed in the developer domain. And then, of course, the developer probably needs some access to an observability backend of some sort, right? Yeah. But you might also come with, if you are a developer, you might want to add your own custom stuff, right? You don't just want whatever is the baseline of your SDKs or frameworks that you are running. And luckily, it's actually fairly easy to do that if you are using the Java agent in this case. So this is in Java. You basically just get the global tracer, and then you can start a trace, and you can end a trace.
For the developers in the room, like that, the nice thing about this, at least something that I found that I didn't know, is that this is just a set of APIs that you can include in your application, and then you can start adding and creating your own spans. And for me, that's exactly what I need, because I don't need any backend when I'm developing my application. I'm just building this, and depending on where this application is deployed, is where the traces are going to be sent and how they are going to be produced and analyzed.
Exactly. And why observability is critical when you're using Dapr? It's really critical because now you're pushing like really critical functionality like database calls, message broker interactions, all of that into a sidecar. So that's why you really want to understand what is going on in that particular part of the infrastructure, right?
With projects like Dapr that sits between your application and infrastructure, projects like Envoy, where you're just routing traffic across something else that is running very close to your application, you are adding complexity by adding more components, right? Now, if you have hundreds of applications, then you have like a bunch of more containers that you need to understand how they work and how they communicate with each other.
Exactly. And it's actually, so asynchronous communication is quite hard to do tracing because traditional tracing at least assumes like the synchronous response, request response. And when you have asynchronous workflows and stuff communicating at random times, the context is often lost, which is a problem. So what we'll come back to that later. So what that could look like for you if you are not propagating your context probably is that you are getting multiple traces instead of having like one coherent trace, which is really what you want to understand what is actually going on in my system. So having something like this where you have multiple traces, it is actually the same thing that is like the full like flow is happening, but you get it in maybe 4 or 5 different traces.
It's really, you need to like figure out how they connect, basically.
That's really not what you want. And then when you're introducing Dapr in the mix, right, now you have the sidecar in between. You need to make sure that all the context is propagated throughout this entire system that you have built. And now with the asynchronous workflows as well, it's just really complex to understand what is actually going on.
So now you have very resilient applications, but very difficult to observe, very difficult to understand what's happening at what point. So
yeah, and this was just to say these two, if you're not familiar with the W3C trace context, this is really what you're passing along. This is the context that you need to propagate in order to create the distributed traces. And I guess now to the demo, because I think you can see the time is running. So you already saw like the front end side of the things. So this is the back end side or the infrastructure side of things. We have a lot of services, the free services running, but we also have the OTel operator for the auto-instrumentation of the Java services. We have the collector running that will, in this case, send telemetry to Jaeger, or just traces, because that's what we'll be looking at. We have the entire Dapr system control plane running. And we did a lot of work to get this working, because out of the box, this doesn't really correlate that well.
I think that we were getting a lot of that, like a lot of pieces and informations about things that were happening, but not the full trace, just to understand how our pizza was actually being delivered and cooked and being thrown around different services. Right? When we talk about like workflows, usually this is kind of like what we think about. Like we think about like sequence diagrams that basically will tell you what happens, and you can add some like business logic into them, right? Like in this case, as I mentioned before, if you ordered pizzas, they will be sent to the kitchen, right? And then the application or the workflow will wait until the kitchen notifies that the order has been already cooked to move next to the delivery, right? And this is kind of like what we are seeing in this diagram, which usually is being used to validate with business users that the application is actually doing what they are supposed to be doing. In Dapr Workflows, you put this into code inside your application so developers can actually define what happens. And again, the idea here in Workflows is that it's just not simple like code in this case that we're showing. It's something like the runtime engine will make sure that we will execute all these activities until they are completed. No matter if the application gets shut down, no matter if there is an issue with Dapr, and no matter if like there are issues with Kafka. Whenever we solve the issues in the infrastructure side that we probably will see on the observability space, the application will keep making sure that this order gets delivered towards the end. I know that you are probably not developers and more interested in infra, but like the workflow definition is basically just code that developers will write inside their applications.
But what is cool here is all the abstractions, right? Because as a developer, you only have to write the business logic in this case, and then you just get all of this out of the box.
And the nice thing about this is that you write it in your own language with your own constructs in the way that you are already used to write, in this case Java, right?
Yes. Okay, so let's have a look at the infrastructure then. So this is just a kind cluster running on my machine in this case. We have the Dapr system running up here with all the different components that are part of that. We have the OpenTelemetry Operator, which was the one that will be doing the auto instrumentation of our Java applications. We have the collector running. We have our services, which is these three. We have Kafka for the asynchronous communication. We have a database as well, and we have Jaeger for our distributed traces to be able to visualize what is going on.
Yeah, and you can see the sidecars there in the application containers, right? Like the two containers running.
So let's have a look at. Let me just describe this part. And what you will see is a few things. So both Dapr and the OTel operator in this case use annotations to basically do a lot of configuration in this case, and also. For this one in particular is to you basically add a tracing configuration for your application, which defines, I'll show it in a second, but it defines where to send the telemetry for the Dapr sidecar.
Yeah, I think that quickly before going there, I want to recap, right? We have our application pod that is running. We have sidecars now, and we have the control plane from Dapr running. And we have also the OpenTelemetry collector that we need to actually wire all together. So all these components, they need to send data to the same place.
Yes, and for the auto instrumentation, you add this instrumentation inject Java in this case, and you point it to a specific instrumentation resource. So let's just quickly, let me just see if I can do it right. So let's just pull out both of these configurations. So on top, you have the OpenTelemetry instrumentation resource, where you define where the collector is running. So we just have a collector running somewhere. We can define all kinds of different things around how to do sampling, how to do adding resource attributes, UIDs for Kubernetes, stuff like that. And for Dapr,
it's just the same.
It's more or less the same. So the top one instruments the application side, and the bottom one here is basically instrumentation of the sidecar that we are running.
Yeah. And at the end of the day, we have different components sending all spans for the same trace, and then they need to be aggregated together, right?
Yes. So how does all of this look? Let me see if I can find. So you saw you saw the demo, and this is basically what happens when you click the order with all the changes that we did. So this is not upstream right now. We are trying to push this upstream so that we actually get this full correlated trace. But what you see is that there's a post on the order endpoint in this case, which basically kicks off the pizza order workflow you just saw in the application. And you get the different activities that are going on in this case.
Yeah. So from a workflow perspective, you can actually see your workflow in action here. All the things that happen in the workflow are kind of like that top level, store order activity, place order to kitchen, and deliver the order to the customer, right?
Yeah, I'm not sure why the visualization looks a little bit weird.
Yeah.
But
should we? I think you need to click in different
spans. We can do that. So if we click on place order to kitchen just for deep diving into one of the workflows, you can see that, so this up here is the pizza store deployment. This is the application side. Then it goes into the sidecar of the Dapr. And then a lot of stuff happens. We are still in the Dapr D, and we go back into the actual application. And now you can see that we're actually interacting with the kitchen service, which then
goes to the application, yeah?
Yes. And then at some point down here, you can see that we're actually preparing the order. This visualization is broken for some reason.
Yeah, I think if you click...
let me just refresh. Yeah, there we go. Now we get the full trace, it's fine. But you can see that this is where time is being spent, and then you can see the same thing if we go down to the deliver order.
9 seconds, yeah.
Yeah, the visualization is for some reason broken in Jaeger right now. I think it's a really long trace.
Yeah.
I don't know. But the whole point of this is really that you can basically, using what the sort of the changes that we did to the sidecar and to some other libraries underneath, is that you get the full trace of the workflow instead of what you saw before. You didn't actually see that, but I will show you.
Yeah.
That in a second was something like this, where you had all the different traces were like separate traces, and we really wanted to see this come together as basically one distributed trace with all the activities going on, so that from the development perspective, you really understand what is going on, all the way down to the actual application code that you write, because that's the interesting part, right?
Exactly, yeah. And I think that this is also important because you can see how much time takes Dapr, for example, just to forward requests across different applications, making sure that you are adding a component and then you are fine-tuning that component to make sure that you keep performance up.
So if we just step back, what works today? If you use the upstream today, you will get a lot of spans from the Dapr sidecar out of the box. They will not be connected for the workflows, but hopefully that will be done when our PRs will be accepted at some point. Open source takes time. You can use the OpenTelemetry Operator to enable the auto instrumentation for multiple languages. You can use the collector as well. You can actually use the operator to manage your collectors if you like that. So all of these tools are available and can do a lot of cool things out of the box of today. But what the challenges we sort of ran into when we wanted to do this was basically this context propagation that we were mentioning earlier, and adding all of those sidecars and all of the things that are going on in this distributed trace when you're actually delegating a lot of responsibility to a sidecar. Was quite interesting. And then there's all kinds of thread and processes and stuff like that. And you need to propagate the trace parent. So there's all these multiple places where things could break, where we need to propagate the actual trace parent in a way. So in some of the cases, it's gRPC streaming. In other places, it's worker pools where we need to make sure that the trace parent can be picked up by the right thread in this case. And then we need to pass it on to actually understand all of this. The one challenge we had with Dapr in particular here is really the way that the actual Dapr communicates with the application side of things, because it basically creates a gRPC stream. So if we were just using auto instrumentation and it was like regular RPC calls, it would have been fairly easy to, it would have worked out of the box. But as this is just one stream that is being generated and messages are being sent over that connection, we need to make sure that that context was also propagated through the gRPC stream.
And I would assume this is gonna it's not the Dapr specific problem. I would assume everybody using gRPC streams will need to basically look into this and just get it done correctly. Yeah.
Exactly. So we created a lot of PRs. So if you're interested, you can check them out. It's on the Dapr project. It's on Doable Task Go, Java, stuff like that. And of course, this is only for the Java part of things that we have been looking into.
But that will propagate to other SDKs as well, of course. Yeah.
But there's still work to be done here. And I think the collaboration between the two projects in this case has really been about how can we help each other improve basically the observability of these projects.
And again, it's going back to that, it's no matter what you're building, it's going to be complex, and each component in your architecture will need to be something about observability, and you need to get it right in order to be able to integrate with the larger ecosystem. So for us, something that started in Japan led to some pull requests, and there is so much work to do in that space that we want to go to other projects and just keep trying to help other projects to get there as well.
Yeah, and I think it's a general problem out there that many projects are not they are very deep dive into whatever problem they're solving, right? But they might not understand completely how to do OpenTelemetry or how to do observability. They might generate a lot of spans that are very particular to the maintainers and not so much the users of that particular tool. And I think there's some really interesting work to be done in this space. But both defining conventions for the different projects and cross projects, and so I think this was a cool collaboration, and hopefully we'll get the PR approved at some point.
Will be merged at some point, yes.
And just remembering that having this separation of concerns between the platform and the developers is really, really awesome, and being able to provide these abstractions so that you as a developer, when you're just writing that simple code in your workflow, you will also get like the full visibility on the other side is really powerful.
Yeah.
And I think with that, yeah, feel free to get involved. We are hanging out in the Dapr and the OpenTelemetry Slacks, in the CNCF Slacks. And yeah, thank you so much.
Thank you so much.
Amazing. Thank you very much. We have time for questions. Yep.
Oh, we have a tough question. Tough question.
Yeah, let's have a tough questions. All right. So you saw on the UI that you were not able to visualize because you have a process that took 16 seconds and the other one was few microseconds. And you can see when you have that, it's very difficult to visualize. Yeah. And specifically in asynchronous calls like this, where you can have a subtask that takes 30 seconds, 40 seconds, and then it just makes a very difficult trace that is very hard to utilize. Yeah. Have you thought about instead of having the option to say, don't attach my span as an actual span to the trace, but use a span link? Yeah. So then the sub-process will start a new trace, and then it will just link it to the previous one. So then you have separate traces, but links together. Yeah. So then it's more easier to consume. Have you thought about it?
Yeah, we definitely discussed that as well, and I think that would probably also be, so right now we basically just wanted to get this started, and I think from what I understand in this space is that like creating spans is very like an art form, and how to like basically set this up. There is some like guidelines on OpenTelemetry of how to do this, but I also know there's like a lot of different opinions on how to use either to do parent-child or do span links. But I think in this case it might make sense to consider doing span links instead. Also for the producer-consumer stuff, like the producer is consuming or like producing something and the consumer is consuming. There could be multiple like consumers on that side, and the parent-child relationship might not hold in that case as well. But yeah, that is definitely some more work to be done in this space. Yeah.
That's something that I've learned in this collaboration. It sounds like it's just like an art form that you need to get into that space and just get it done and understand exactly what's the thing that the user is looking for when they are looking into these traces, right? One mega trace doesn't make sense, so you need to segment that out in some way that is meaningful for the user. And in this case, we have like high-level concepts like workflows, so it kind of makes sense to have one trace that actually show you what happened there. But or like just the visualization from the application point of view and not the infra side of things, right? Yeah. Because the infra will be adding a lot of spans as well, and maybe you're not interested in that at all.
Excellent. There's a quick question then. We have 1 minute.
I have a question about how do you manage the traces? Is it on all the time, or do you activate it as just some time to troubleshoot?
You go with that?
Yeah, so right now we are just basically tracing everything. We're not sampling or anything like that. So we just, for demo purposes at least, but of course when you go to some scale, you probably need sampling. But for this, it's really nice when you're like debugging stuff that like 10% of your traces is not disappearing. So so for this demo, it's all everything is being pushed into Jaeger in this case.
But at the same time, it's declarative, right? So you can actually change those configurations whenever you need them.
Yeah, and you can do that both in the as you saw in the instrumentation resource, but also in the tracing config for Dapr. You can control the sampling rate.
Good stuff.
Thank you.
Excellent. So we can also continue the discussion as they suggested here in the networking, but also in the open source and upstream communities. I would like to thank both for speaking. Nice. So you get a
tape.
I need a tape, yes.
We'll distribute tapes today, so someone will get the Higgs boson. Awesome. And you also get our chocolates from our local event that will happen
next week. Is it like a Bitcoin hard drives that you keep them for 20 years and then they value like...
Well, you never know. You never know. You'll have to wait 20 years to see if that happens or not. Okay, thank you very much again.
Thank you.
Thank you.